Okay, now we'll see some of the worked examples under two conditions, that is type 1 and type 2 of compound interest. So based on that, we have a first worked example. Determine the effective interest rate in the following cases. So we need to calculate the effective rate of interest. First one is nominal rate of 12% compounded monthly with a time interval of 1 year. Nominal rate of 18% compounded weekly with a time interval of 1 year. Then third one, nominal rate of 13% compounded monthly with a time interval of 2 years. Nominal rate of 9% compounded semi-annually with the time interval of 2 years. So for this condition, we need to calculate the effective rate of interest. Now we know the formula for the effective rate of interest, that I effective is equal to 1 plus small letter I divided by C whole to the power of C. C is what? Number of interest period per year. So first one, compounded monthly with the time interval of 1 year. So compounded monthly means how much? 12 months in a year. We know that we are going to consider the effective rate of interest within a year. So if it is compounded monthly means 12 months. So in place of I, the rate of nominal rate of interest 12%, 0.12 divided by C, compounded monthly means 12. Here also put in place of C put 12, so we will get 12.68%. This is for compounded monthly. Similarly, for the nominal rate of 18% compounded weekly with 1 year. So for the nominal rate of 18% compounded weekly with a time interval of 1 year, so we'll get 19.68%. 19.68%. 52 is what? The 52 weeks in a year. Next, for the third condition, nominal rate of 13% compounded monthly with a time interval of 2 years. So rate of interest is 0.13 and compounded monthly again 12. So we'll get 13.80%. And next we have nominal rate of 13% compounded monthly with a time interval of 2 years. See, here they have given with a time interval of 2 years. Since we are calculating the effective rate of interest, we are going to consider only per year, because for the next year also it is same. So for that we will get 13.80%. Next, nominal rate of 9% compounded semi-annually means 2 times in a year. So it will become 9.20%. The formula is important. If you know the formula, you can calculate the effective rate of interest. So in the similar fashion, we have one more problem. Find the effective rate of interest for an actual rate of interest 10% when compounded yearly, biannually, quarterly, monthly, daily, hourly, continuously, means infinite. So for this we need to calculate the effective rate of interest. It is also same. The formula I effective is equal to 1 plus 0.1, the given rate of actual rate of interest 10%. So 0.1 by yearly means per year is equal to, will get 10%. That is for a year. Now biannually means 2 times in a year. So we'll get 10.25%. Same formula, but in place of C, number of duration. So for that you have to enter 2. Then quarterly. So for the quarterly we know that it is 4. So for that we'll get 10.38%. Then monthly, monthly means we have a 12 months in a year. So we'll get 10.47%. Then daily basis, there are 365 days in a year. So we'll get 10.515%. Then hourly basis, 365 into 24. In place of C, you should write 365 into 24. So you will get 10.51%. Then infinitely, last one. For that we have a separate formula here. I effective is equal to e to the power of I minus 1. E to the power of I minus 1. So for this, I we know that 0.1. So e to the power of 0.1 minus 1 will get 10.51%. So this is how we are going to calculate the rate of interest. And in VTO exams, usually they will ask the question based on the effective rate of interest. So this is very, very important as per the exam point of view. Now we will see the third type of compound interest, that is equal payment series compound amount. Equal payment series compound amount means the condition for this type is f by a comma I comma n. F by a means how we are going to read it? To find f, a is given. To find f, a is given, which means f means what? The future sum of amount, and a is equal amount deposited at the end of each interest period. Means at the end of each interest period we are going to deposit certain amount in equal number of payments. So that is what our A. F is the future sum of amount, so that we are going to get in the after certain duration of time. Now the formula to find out the future sum of amount is F is equal to A into 1 plus I whole to the power n minus 1 divided by I. A into 1 plus I whole to the power n minus 1 whole thing divided by I. So here F is what? Future sum of amount, and A is equal amount deposited at the end of each period, and I is the rate of interest. So the cash flow diagram for this type, here we are paying the equal amount, means equivalent amount at certain number of period. Means in the previous types, in a single shot we are going to deposit or we are going to invest certain amount, and after certain duration of time we will get the future sum of amount. But here we are investing or we are depositing the amount in equal number of periods of the same amount. So here we are depositing the equal amount in at a certain number of periods. So that means cash outflow. You are depositing means you are investing means cash outflow. So that's why I have shown the downward arrow mark. Downward arrow mark. Downward arrow mark represents the cash outflow. Here cash outflow is equal amount deposited at the end of each interest period, and after certain number of duration, maybe 10 years, 15 years or 15 years, so we will get future sum amount, that is F. That is what? That is the cash inflow to us. So that is why I have shown the arrow mark upward for the future sum of amount. So this is how we are going to draw the cash flow diagram for the equal payment series compound amount. So next type, with respect to this, we have next type, equal payment series sinking fund. Equal payment series sinking fund means the condition is A by F comma I comma N. Means F is given to find the A. We need to find A by using F. F means what? Future sum of amount. Here we will know the future sum of amount. For example, after 10 years if I want 5 lakhs means what will be the equal amount or the installment amount that I need to pay every year for 10 years or 5 years or 15 years. So that is what the equal payment series sinking fund. Here in the third type we are going to find the equal amount, means the installment amount for every interest period to get the future sum of amount. But here in the fourth type we know the future sum of amount. To get that amount, what will be the equal payment amount that we need to deposit every interest period. So now we are going to solve the problems on third type and fourth type. So we will get to know in detail regarding these conditions. Problem on third type, equal payment series compound amount. Problem on equal payment series compound amount. A 45-year-old person is planning for his retired life. He plans to divert rupees 30,000 from his bonus as investment every year. From his bonus as investment every year for the next 15 years. Means he is planning for his retired life and he is getting the bonus amount as 30,000 rupees and he will invest that 30,000 rupees till 15 years from now onwards till 15 years. The bank gives 12% interest rate compounded annually. This is important. The bank gives 12% interest rate compounded annually. Find the maturity amount of his account when he is 60 years old. Means now he is 45 years old. He is getting 30,000 rupees as his bonus amount. He wants to deposit it as a investment amount for every year till next 15 years. So for that we need to calculate the future sum of the amount after 15 years that old person will get. So now we will see the solution for this problem. To find out the future sum of amount, we know the formula F is equal to A into 1 plus I all to the power n minus 1 divided by I. Now here A is what? The equal amount deposited at the every interest period. How much it is? 30,000. That old person is getting the 30,000 rupees as the bonus amount. So that is what the A here, 30,000. And is planning for next 15 years. The time duration is small n, that is 15. And rate of interest, the bank will give the rate of interest 12%. So that is what? 0.12. 12% means 0.12. Now we have to find out the future sum of amount. So now just apply these values in place of A 30,000, in place of I 0.12, in place of small n 15. So if you simplify this, you will get future sum of amount as 11,18,391 rupees. 11,18,391 rupees after 15 years. After 15 years. So that old person, if he invests 30,000 every year till 15 years, so after 15 years that old person will get the future sum of amount as 11,18,391 rupees. Now for this we need to draw the cash flow diagram. So how we are going to draw this is investing 30,000 in every year as a depositing amount or deposit amount, like cash outflow is paying to the bank, right? Means the cash outflow. So downward arrow mark till 15 years. No need to show all the 15 years. You can show any 3-4 years. So at last you just mention the total number of duration, that is 15. That's enough. So because for every year the equal amount deposited at the end of the each interest period is same. It is not varying, it is same. So you just show till 5 years. So at the end of this you just write 15. So it will understand as the total number of duration is 15 years. So the equal amount 30,000. So this is how we are going to draw the cash flow diagram for the third type, equal payment series compound amount. In a previous type we are investing some amount in a single shot, and after certain duration of time we will get the future sum of amount. Here we are investing the amount in equal number of periods. So after equal number of periods we will get the future sum of amount. So now we will see the fourth condition. So based on the fourth condition, that is equal payment series sinking fund. Equal payment series sinking fund, A by F means to find A, F is given. We have to find out the A by knowing the F. Now we'll solve the problem on fourth condition. A person estimates an expenditure of rupees 10 lakhs for his daughter's wedding about 8 years from now. So 8 years from now is planning for his daughter's wedding of the expenditure amount rupees 10 lakhs. He plans to deposit an equal amount at the end of every year for next 8 years. For the next 8 years at a rate of interest of 11%. Rate of interest of 11%. Compounded annually. Compounded annually. This is important. Compounded annually. Find the equivalent amount that must be deposited at the end of every year for the next 8 years. Just reverse of your previous problem, that is on third condition. There you have the annual equal amount. So for that you have to find the future sum of amount. Here we know the future sum of amount means that person needs 10 lakhs rupees. 10 lakhs rupees for his daughter's wedding after 8 years. So to get the 10 lakhs rupees after 8 years, what is the equal amount that he has to deposit now? So for that we have a formula. A is equal to F into I by 1 plus I whole to the power n minus 1. The same formula, just I have modified to A. Now here I know the value of F 10 lakhs, I rate of interest 11%, 0.11, and N duration, that is 8 years. So if you simplify this, you will get the equal amount for every year is 84,321 rupees. 84,321 rupees means that person has to deposit or invest 84,321 rupees every year. Every year he has to deposit. So after 8 years he will get 10 lakhs rupees for the rate of interest 11%. For the rate of interest 11%. So this is how we are going to solve based on the fourth condition, equal payment series sinking fund. Equal payment series sinking fund. To find F, to find A, F is given. But in the third type, to find F, A is given. To find F, A is given. But here to find A, F is given. So this is how we are going to solve the problem based on the third type and fourth type. Now we will see the fifth type in compound interest, that is equal payment series present worth amount. Equal payment series present worth amount, and the condition for this is P by A, I, N. Means in the previous types we have calculated for the future sum of the amount. By knowing the future sum of amount, we have calculated the equal amount for every year, and also to get the future sum of amount, what will be the equal amount that we need to pay from now onwards. So that we have solved in the previous condition. Here with respect to present worth means P, present worth, like a principal amount or a depositing amount. So that we need to find out when A is given, the equal amount for each interest period. So by knowing the A, we are going to calculate P. So that is why the name is given as equal payment series present worth amount. And the formula to find the P is equal to A into 1 plus I whole to the power n minus 1 divided by I into 1 plus I whole power n. Here P is what? The present worth amount or the principal amount. A is annual equivalent amount. So the amount which are paying in annually or yearly. So that is what? A, equal amount. And the cash flow diagram for this type of condition is P. It is indicating downwards, means what? Cash outflow means a person has to invest the amount or deposit the amount, means that is the cash outflow. So that is why it is indicating towards downward. And the A, the equal amounts, so that has been shown by the upward arrow mark. Why? Because that is the cash inflow, means if I am depositing some amount, so for that I will get some interest amount, that is the revenue for me. So that is what? Cash inflow. So that is why I have shown the upward arrow mark. And after certain number of time, so we'll get the that required amount for the investing amount. So in the previous condition, to get the future sum amount, we are investing some amount, equal amount, just like the installment, and here we are depositing some future fund or some amount, total sum of amount. For that we are getting some interest amount for every year. So that is what our fifth condition, equal payment series, present worth amount. And in the same way, we have a sixth type in compound interest. Sixth type, equal payment series, capital recovery amount. Capital recovery amount. It is nothing but just like your loan procedure. So bank will give some amount and you have to pay the EMI. So that is what this sixth type will say. Equal payment series, capital recovery amount. A by P means we have to find the A, equal amount, means what? The EMI amount. When P is given, means when you know the principal amount, that what you have taken from the bank, so that is what the principal amount. So for that you are paying the interest along with some of principal amount. So that is what your sixth condition, capital recovery amount. And the diagram, cash flow diagram for the sixth type is P is showing upward, means what? Cash inflow, means you are taking loan from the bank, means the amount for you is cash inflow. So after that you are going to repay the loan amount for every year or for every month. So that is what the cash outflow, means you are paying to the bank. So that is what the equal amount for every year that you are going to repay to the bank. That is why I have shown this towards downward. So this is how we are going to draw the cash flow diagram for the sixth type. Now we will solve the problem on fifth and sixth type. Now we will solve on fifth type, equal payment series, present worth amount, means we have to find P when A is given. A person wants to give scholarship to poor students to the tune of rupees 25,000 every year. So a person wants to give scholarship for poor students. So for that he need 25,000 every year. 25,000 every year in the memory of his late father. He wants to deposit a lump sum in the bank which makes him receive the required amount every year for the next 20 years. For the next 20 years. The reserve is assumed to grow annually at the rate of 9%. Find the single payment that must be made now as the reserve amount. So now to give the scholarship amount 25,000 rupees per every year, how much he has to deposit now? So that is what P. We need to calculate P when A is given. Means 25,000 rupees is the A, P is that we need to calculate. Apply the formula. P is equal to A into 1 plus I whole to the power n minus 1 divided by I into 1 plus I whole power n. Just apply the values here. In place of A 25,000, in place of I 0.09 because it is 9%, and n small n duration, that is 20. So the P is 2,28,213 rupees. 2,28,213 rupees means that person has to deposit 2,28,213 rupees. So for this cash flow diagram is, he has to deposit now of 2,28,213 rupees, means cash outflow. He has to deposit to the bank. So means it is cash outflow. So after 20 years, means next 20 years, he will get the equal amount of 25,000 every year. Every year. So this is about a fifth condition. Now we will see the problem on sixth condition. ICICI Bank is offering rupees 30 lakhs home loan to a person to buy a new apartment at an interest rate of 7.5%. 7.5%. Compounded annually. Compounded annually. So this is important. You have to check whether it is compounded annually or compounded semi-annually or quarterly. This amount should be repaid in 15 yearly equal installments. 15 yearly equal installments. Find the annual installment amount the person has to pay to the bank. It is just like a home loan. The bank is offering 30 lakhs rupees and the duration is 15 years. The rate of interest is 7.5%. Just apply the formula. A is equal to P of 1 plus I whole to the power of n divided by 1 plus I whole to the power of n minus 1. The same formula of your fifth condition I have just modified with respect to A. Now apply the values here. In place of in place of P we have 30 lakhs rupees, that is the total amount. Then rate of interest 7.5% means 0.075 and small n duration, that is 15 years. So a person has to pay 3,39,861 rupees per year. 3,39,861 rupees per year. And for this cash flow diagram is, so is getting the loan amount from the bank, means it is cash inflow to the person. So that is why I have drawn upward arrow mark. And till next 15 years he has to repay the EMI amount. So that is what cash outflow means. A person has to repay the amount to the bank. So that is what cash outflow to a person. And for the bank it is inflow. For the bank it is inflow, for a person it is cash outflow. So this is how we are going to draw the cash flow diagram. Now we will see the last type of compound interest, that is seventh type, uniform gradient series annual equivalent amount. Uniform gradient series annual equivalent amount. We are going to calculate the A, that is annual equivalent amount. So A is equal to A1, this is A1 plus or minus G, capital letter G, into 1 plus I whole to the power n minus I into n, I small I rate of interest into n number of interest period minus 1 whole thing divided by I into 1 plus I whole power n minus I. So this is the formula to calculate the annual equivalent amount in uniform gradient series annual equivalent amount. But here A1 is first installment amount, means at the very first time I am going to invest, for example I am going to invest 50,000 amount. So thereafter I will increase it by 5,000 or 10,000, so 55,000, 60,000, so like that. So A1 is the first installment amount. Then G is increment for successive installment. So this we will be indicate by positive or negative sign. Positive means incremental G for every year, means I am going to increase 5,000 or 10,000 for the first installment amount. So that is what the positive sign indicates, increasing the incremental amount. Then negative sign is indicating decrease in G in every year. So if we consider negative sign means the gradient amount is going to decreases. So this is nothing but quite similar to your previous problem, but here the thing is, for the first installment amount we are going to add some of the extra amount. So that is what the G, that is the incremental amount for the successive installments. So for that we call it as the uniform gradient series, uniform gradient series. And for this cash flow diagram will be, so means we are paying the installment amount, means cash outflow, so the arrow mark should be in downward direction. So at the first year, A1, the very first installment amount, A1 is the first installment amount, then A2, A1 plus G means the first installment amount plus the next successive amount that you should add, whatever it may be, 5,000, 10,000, 50,000. Then next in the third year, A1 plus 2G means again you are going to increase the amount. So like that, after n number of periods, so A1 plus n minus 1 into G. So this is how we are going to draw the cash flow diagram for this type. You should remember A1 plus or minus G. A1 is the first installment amount and G is the incremental amount for successive installments. So now we will solve one problem based on the seventh type, that is uniform gradient series annual equivalent amount. A person wants to gift a car to his daughter when she would turn 18 years. When his daughter would turn 18 years, so he wants to gift a car for his daughter. 6 years from now, he decides to put away money in her name during her next 6 birthdays. He wants to deposit rupees 25,000. He wants to deposit 25,000 in the first year and go on increasing it by rupees 5,000. So the first installment amount will be 25,000 or the first investing amount. Then it will be increased by 5,000 every year for the next 6 years. So if he estimates that a car would cost of rupees 5 lakhs when he wants to buy one, how much more money should be added to the maturity amount that he receives from the bank if it is assumed to grow at 11.5% compounded annually. This is important. Compounded annually means the problem is simple. A person wants to gift a car for his daughter. So after 6 years, so he need 5 lakhs rupees. So for that he is investing of the amount rupees 25,000 for the next 6 years. But this 25,000 amount will be increased every year by the amount of rupees 5,000. So bank is giving 11.5% interest for compounded annually. So for this we need to calculate the future sum of amount, what is the maturity amount, and after getting the future sum of the amount, you should verify that how much more money that he should add it to get 5 lakhs. So as per the given data, A1 is how much? 25,000, G 5,000, the successive installment amount means it is goes on increasing, means we should use positive sign. I, rate of interest 11.5%, N, the number of duration 6 years. So A we need to find out first, then after getting A we need to find out the future sum of amount. So to find out A means what? Annual equivalent amount. So for that we have a formula, A1 plus, why it is plus? Because the first installment amount, that is 25,000, is increased by 5,000 on next every year. So we should take positive sign, plus g into 1 plus I whole power n minus I into n minus 1 whole thing divided by I of 1 plus I whole power n minus 1. Just apply the values here, simplify it. So you will get A 35,924 rupees. 35,925 rupees. That is what A. Now you have to find out the future sum of the amount. So as per your previous type of the problem, means when A is given, to find F. So for that condition, use that formula. F is equal to A of 1 plus I whole power n minus 1 divided by I. Means when A is given, we can find out the F. To find F, A is given. So I am using that condition to find out the F. So just apply the values here. In place of A 35,924, in place of I 0.115 because 11.5 interest, then n 6 years. So you will get future sum of amount F is equal to 2,87,872 rupees. 2,87,872 rupees. But he wants to gift a car of 5 lakhs rupees. But he will get the future sum of amount 2,87,872 rupees. So if you minus 2,87,872 rupees from 5 lakhs, so we'll get 2,12,127 rupees. 127 rupees. The extra amount is 2,12,127 rupees that he should add to 2,87,872 rupees to make a total sum of 5 lakhs rupees. Total sum of 5 lakhs rupees. So this is about the 7th type of compound interest, that is uniform gradient series annual equivalent amount. Suppose in place of it goes on increasing, suppose if you get any decreasing amount in different kind of problem, so you have to use the negative sign. That's it. So and for this the cash flow diagram is also simple. In the same way, means downward means you are paying to the bank, right? So it means cash outflow. So just show the downward arrow mark. Downward arrow mark. So this is all about the all 7 types of the compound interest. So if you remember the condition and formula for all the 7 types of compound interest, so it is easy to solve the numerical problems based on the compound interest types. Now we have a small concept, microeconomics and macroeconomics. Economics means what? The study of how humans work together to convert available resources into goods and services and to earn profit and benefits. So based on this, we are going to categorize into 2 different ways, microeconomics and macroeconomics. Microeconomics means it is the economical behavior of an individual unit. Macroeconomics means it is the economical behavior of the whole unit. For example, a state government and a central government. A state government will take care of the state, particular state, but central government will take care of the country, right? So this is how we are going to categorize the economics into microeconomics and macroeconomics. We will see the comparison between these 2 concepts. So based on the parameter, we are going to compare the microeconomics and macroeconomics. First one, definition. So based on the definition, the branch of economics that studies the behavior of an individual unit is known as microeconomics. Means a single unit, for example a customer or a family or a product, so like that. So if you focus on a particular individual thing, so if you study the economical behavior of that particular thing or the individual unit, so that is what the microeconomics. In the same way, for macroeconomics, the branch of economics that studies the behavior of whole economy is known as macroeconomics. Means the macroeconomic studies will focus on the whole thing, the whole economy of a particular country or a particular nation. So that is what the macroeconomics. Next, it deals with individual economic variables. As I said, it will focus on the individual products or individual team or individual customer, like that. So next, aggregate economic variables. So macroeconomics will focus on aggregate economic variables. Next, business applications. So in business applications, it will apply to operational or internal issues. So the application for the macroeconomics will be like the internal issues or the operational issues. So that will focus on within the team or within the individual unit. Then for macroeconomics, it is environment and external issues, just like import and export, weather conditions, so like that. So it will focus on environmental and external issues. Then we have fourth parameter, approach. So the approach of microeconomics is, it is a bottom up approach to economy. Bottom up approach means we have a hierarchy: workers, supervisor, manager, a divisional general manager, or a CEO, director, like that. So we are going to follow that hierarchy to do a function or to do a service. So based on that, we are going to receive the order from our higher authority and will follow it, right? So in the same way, the economical behavior will follow the bottom up approach. And for the macroeconomics, it is a top down approach to economy. Means it is from top to bottom. Means he will order for the entire thing or for the entire unit and they have to follow. So that is what it is, a top down approach to economy. Then allocation resources. So it focuses on allocation of resources among individuals. As I said, it will focus only on the individual resources. Then macroeconomics focuses on allocation of resources among the groups of market segment and market segments. So these are some of the comparison between microeconomics and macroeconomics. So in these two type of economics, we are going to analyze the behavior of the economics. So this is what the given syllabus for your third module, that is Introduction to Engineering Economics. Thank you.